Many students seem to have some trouble with the gas law problems, and that's completely understandable because I haven't shown you in person how to do it. So the first problem I have right there, hold on one sec. So the question is, a given mass of air has a volume of 6 liters at a pressure of 101 kilopascals. If the pressure is reduced to 25 kilopascals, what will be the new volume? So the formula you want to use is P1 times V1 equals P2 times V2. And you plug in the variables that you identified from the word problem, and you get 6 liters times 101 kilopascals will be equal to 25 kilopascals times our unknown volume. Well, we need to isolate our volume, our unknown volume, so we divide both sides by 25 kilopascals. It cancels on the right side of the equation and is transferred to the left side. So then we have 6 liters times 101 kilopascals divided by 25 kilopascals. Notice you have a kilopascal in the numerator and the denominator, so they will cancel, leaving you with a unit of liters. And when you carry out the math, you get an answer of 24.24 liters. So number 2, the question says, a gas in a closed container has a pressure of 300 kilopascals at a temperature of 30 degrees Celsius. An unknown new pressure will be found when you change the temperature to negative 172 degrees Celsius. So first things first, notice temperature has to be converted to Kelvin. All you have to do is add 273 to your Celsius temperature and you get your Kelvin temperatures. That is your absolute value for your temperature, and you need that for all gas law problems. And then the second thing, first we converted temperatures. Second, we identified all the variables from the question, including the unknown, and then you write your formula. Always take the time to write out these steps because it helps so much to solve problems. It keeps you organized. Once you have your formula and your variables, plug those variables into the formula and carry out your math. So we had 300 kilopascals divided by 303 Kelvin is equal to an unknown pressure divided by 101 Kelvin. So when you carry out the math, you multiply both sides by 101 Kelvin in order to isolate your unknown. And so you have 101 Kelvin times 300 kilopascals divided by 303 Kelvin, and you get a value of 100 kilopascals. So your Kelvin temperature unit cancels, leaving you with pressure. One thing you always want to do is make sure it makes sense. So in the pressure and temperature relationship, it's directly related. If one goes up, the other goes up. If one goes down, the other goes down. So look at what happened. Our initial pressure was 300. Our initial temperature was 303. Our ending pressure, we don't know, but our ending temperature is lower by 3. A multiple of 3. 101 times 3 is 303. So our pressure will also be lower, and in this case it's a direct proportion, so it's lower by a multiple of 3. So 300 divided by 3 gives you 100 kilopascals. If we go back to question number 1, this is an indirect relationship. When one goes up, the other goes down. So in this case, we started with 6 liters and 101 kilopascals. What's our new volume if our pressure decreases? Well, since our pressure decreased, our volume should increase. Well, we went from 6 liters to 24 liters. That is an indirect relationship. You always want to make sure that you check your work to ensure yourself that it makes sense, because if you see a pressure increasing and a temperature increasing, if you see something like question number 2 where the temperature increases, you would expect an increase in pressure or a decrease in pressure. And you just want to make sure it matches. In number 3, the question says, calculate the volume of a gas with a pressure of 100 kilopascals if its volume at 120 kilopascals is 1.5 liters. So write down your variables. 1.5 liters, 120 kilopascals is initial, and final is unknown volume, and 1,000 kilopascals. Uh-oh. Okay, so 100 kilopascals, not 1,000. I corrected my math. So your formula is P1V1 equals P2V2, 1.5 liters times 120 kilopascals equals 100 kilopascals times our unknown volume. Divide both sides by 100 kilopascals to isolate your unknown variable, and you get 1.8 liters for the new volume. Does the answer make sense? So remember, this is an indirect relationship. When one goes up, the other goes down. So we went from 1.5 liters and 120 kilopascals to 100 kilopascals. Pressure went down, so volume should go up. 1.5 liters to 1.8 liters, our volume increased. That makes sense. So moving on to number 4. The question says, a sealed cylinder of gas contains nitrogen gas at 1,000 kilopascals and a temperature of 20 degrees Celsius. The cylinder is left in the sun and the temperature increases to 50 degrees Celsius. What is the new pressure? So our information, 1,000 kilopascals for pressure and 20 degrees Celsius, which is 293 Kelvin. Our unknown new pressure at 50 degrees Celsius, which is plus 273 gives you 323 Kelvin. A direct relationship, when one goes up, the other goes up. So we should expect a value of P2 to be greater than 1,000 kilopascals. Plug in your variables. 1,000 kilopascals divided by 393 Kelvin. Unknown pressure divided by 323 Kelvin. That should be 293, sorry. When you carry out the math, you get 1,102.4 kilopascals. Our pressure increased the same way our temperature had increased. The next problem, number 5, says a 5.009 liter air sample at a temperature of negative 50 degrees Celsius. Sorry, reading number 6. Number 5, a gas with a volume of 0.3 liters at a temperature of 150 degrees Celsius is heated until the volume is 0.6 liters. What is the new temperature? Volume and temperature have a direct relationship. When one goes up, the other goes up. So the formula is V1 over T1 equals V2 over T2. So plug in your information. 0.3 liters divided by 423 equals 0.6 liters divided by T2, our unknown. So this one's complicated because your unknown variable is in the denominator. Multiply both sides by that unknown to get it in the numerator, but it ends up on the other side. Multiply both sides by the inverse of the fraction on the left side of the equation. So you end up with T2 equals 0.6 liters times 423 Kelvin divided by 0.3 liters. And T2 is equal to 846 Kelvin. If you look at the relationship between the volume, Your initial volume was 0.3, your ending volume is 0.6. It's 2 times greater. Well, look at your initial temperature, 423, and remember it's a direct relationship, so your final temperature should be 2 times greater. So 846 makes sense. Number 6, what I already started reading. This one is the combined gas laws. You have pressure, volume, and temperature variables in one problem. The question says a 5.009 liter air sample at a temperature of -50 degrees Celsius is at a pressure of 107 kilopascals. And then, what will be the new pressure if the temperature is raised to 102 degrees Celsius? So that's a very big increase in temperature. And the volume is increased to 7 liters. So an increase in temperature will increase the pressure. A decrease in volume will an increase in volume will decrease the pressure. So what will our answer be? First of all, your formula, P1V1 over T1 equals P2V2 over T2. Plug in your variables. So 107 kilopascals times 5.009 liters divided by 223 Kelvin is equal to our unknown pressure times 7 liters divided by 375 Kelvin. Rearrange and solve for your unknown, and you get an increased pressure of 128.8 kilopascals. And the final problem, number 7. The question says a gas at 155 kilopascals and a temperature of 25 degrees Celsius occupies 1 liter container. If the pressure is increased to 605 kilopascals and the temperature is increased to 125 degrees Celsius, what is the new volume? Again, we're using our combined gas law. Pressure 1 times volume 1 divided by temperature 1 is equal to pressure 2 times volume 2 divided by temperature 2. Plug in the variables. We get 155 kilopascals times 1 liter divided by 298 Kelvin is equal to 605 kilopascals times our unknown volume divided by 398 Kelvin. Rearrange to isolate your variable of volume 2. Solve the math. You would end up with 398 times 155 times 1, divided by 605 times 298. And you get an answer of 5.21 liters. Does the answer make sense? It went from 1 liter to 5.2 liters. Our pressure increased significantly. So that would mean our volume will decrease. When pressure increases, volume decreases. But our temperature increased significantly also. And when when temperature increases, so does volume. So in this case, the change in temperature played a bigger part in the change in volume than the pressure change did.